או של...
אני הייתי שם כבר את השקף הראשון.
שם.
יאללה, אני וחגי על מיוט. Welcome all the early birds. In a few minutes, we will start the webinar. We'll just wait for other registrants to attend and we'll open the webinar. Hello, everyone. We're waiting a few minutes for more people to attend, and then we'll start the webinar.
Okay. Hello, everyone. This is a webinar that we're going to conduct on a live demo of Kubernetes data replication. Simply deploying things in cloud is not an easy task, but replicating data, accessing that data, whether it's a hybrid or even a multi-cloud environment, is even tougher. Yaki Ratz and myself, Tal Doron, will be hosting the webinar on behalf of Gigaspaces, and we'll discuss the challenges and the solution that we can offer in that respect. Both of us are solution architects, and we would love to meet and speak with anyone who has a challenge that we can probably help resolve. So just a moment before we dive into the challenges, a word about Gigaspaces. Gigaspaces has been around for over a decade, solving in-memory compute challenges, consolidating data from different data sources into a single digital integration hub, and is deployed in hundreds of customers worldwide. This solution is a distributed solution running on-prem, cloud, hybrid, and customers who are using this solution are enjoying enterprise-grade solution to consolidate data and access that data in a real-time manner. So let's see what are the four major, I would say, cloud and Kubernetes data challenges. So how do you deploy a hybrid platform or a multi-cloud platform? That's one type of challenge. Synchronizing data changes across sites, not an easy task. Storing data in Kubernetes for stateful applications and replicating data from relational databases to semi-structured document databases and vice versa. So we have all this, I would say, polyglot kind of persistence, different databases, different data types. And let's drill into each and every one of them and see what are the type of challenges we're facing. So deploying a hybrid or multi-cloud platform. Well, the fact of the matter is that on-prem we have variable machines, VMware. Now we see more and more Docker and OpenShift. And on the cloud, we're talking about Kubernetes deployments. So we have this kind of hybrid environments that we need to deploy. Now, on-prem, we already have solution stacks. Most of them are not cloud ready. And on the cloud, we find cloud native solutions, which are parallel solutions, but require a completely different type of expertise. On-prem databases, especially for a lot of organizations, are mostly conventional. And on the cloud, we see different types of databases, more of the type of key value, document, text-oriented, etc. So we have to understand how we kind of organize and replicate data from where to where, how we do it, what type of transformations are required. So we have this huge challenge of this hybrid platform. The second one is synchronizing data changes across sites in real time. So a lot of us are familiar with change data capture tools, which replicate changes from one log to another target, but it doesn't start or doesn't end with that. We have to understand how we integrate with legacy databases such as DB2 and on-prem DB2, for example, and replicate it to a cloud native databases. Make sure that we can handle conflicts, reconciliation, multiple CDC streams, restarts, onboarding new tables or schema evolution of tables into the CDC streams without any downtime. We have tons of challenges around syncing data between, especially between two completely different environments. So we want to create a single source of truth. That's ultimately what we want to do. But how do we create a single source of truth if we have completely different environments? Well, caching is a solution that would have been acceptable a few years ago, but today it's not enough. Just caching data, we need a few steps beyond just caching. We need to resolve all the challenges that were just mentioned. But we're still halfway through. We still have two more huge challenges. Managing data using stateful applications. Well, it's not enough to store data in databases. We need to access that data. But if we store it in a non-local database, well, the performance will be high. But if it is a directly attached storage, well, how do we handle scaling? So we have a relational database, which is directly attached on the same instance as the application. What now? Well, of course, we can mount drives. That's great. And we can access shared data between multiple containers. But now we have to understand how we maintain distributed transactions, manage data integrity, and every customer that I met has always asked me, what about data integrity? It's not something we can just ignore. Cloud block storage is a great solution for, I would say, more data lake oriented approach. It's cheap, you can store tons of data, but you're kind of losing the real-time, the zero latency operational capability. So it's definitely good for certain use cases, but it doesn't solve the bigger picture. The fourth challenges, and here we chose to illustrate it using a sequence flow, is, well, how to replicate data from a RDBMS to a semi-structured document store. There is so much we need to do in between. We need to catch the upserted data for TP2, for example. We need to capture it from the logs. We need a CDC tool to capture the changes. We need to create a data pipeline to process the data. We need to understand the column types, transactions. We need to understand how we handle the write, all or nothing, or can we lose data? Probably not. Zero data loss, that's kind of where we look to. And we need to handle reconciliations. We need to make sure data is immediately available for consumption. It's not enough to write data like in a Lambda architecture to a, I would say, to a slow data store and have the data available after an hour. We need it immediately available. So, and the last one, also making sure we have a disaster recovery site for everything. So this is a huge, huge challenge we need to make sure we can handle. And it's really not obvious. So our ultimate goal is build a low latency hub for digital applications across clouds without compromising data integrity. Well, sounds simple enough, but is it? Well, I see a lot of organizations trying to use all kinds of different tools. Some of them are cloud native, some of them are not. And ultimately, I see this often convoluted architecture to achieve this simple goal. Now, if we're looking just on the data replication aspect, this is mostly what we want to achieve. We want to be able to replicate data from CDC to some kind of a layer. That layer is immediately, you can consume the data from that layer, but we need to make sure we can replicate between environments. We need to make sure we have data pipelines. Everything here should be TCO friendly. And we need to serve the data in real time. And we also need to push it to other data stores in other environments. Well, this is quite a mouthful. So running a hybrid or cross-cloud, what we call digital integration hub, and I'm saying we adopted the analyst view of this kind of very, very specific, I would say, data fabric implementation called DIH, Digital Integration Hub. We've taken everything and we've made everything simple with a single platform. So focusing on Gigaspace's Digital Integration Hub, and this is our offering, we're actually looking at the complexity to see what exactly are we solving. Well, we mentioned before we have this on-prem existing architecture. It's a given. Our organization already have products to store the semi-structured data, the relational data for transactions, the microservices, the replication tools, and each one has its pros and cons. There is no best tool. Each one has its pros and cons. But the fact of the matter is that the bigger picture here is that we have to maintain this entire environment. We need to monitor it, manage it, completely automate it, part of our CI/CD process, and make sure we can evolve it to new digital use cases, which are kind of being born in a daily manner. Now, take this entire complexity and rewrite it on a cloud, on one cloud, or another cloud, on 3 clouds. What now? We have to maintain different environments, different products, because each cloud has its own native solutions. And ultimately, we find ourselves that we have to maintain multiple applications, different environments, different monitoring tools, different cost assessment tools. Ultimately, it's no secret. Cloud vendors have an interest to migrate the data to the cloud, while organizations, and I've recently heard the number, over 40%, are also moving data back to on-prem from different considerations, whether it's cost or security. So the reality is that hybrid deployments are, well, that is the reality. So how can we make this picture simpler? Well, this is it. We can consolidate data from different data sources and different file types, different APIs, to a smart DIH, serve the data in real time after we replicate it to this distributed environment. And while we're doing that, we can replicate it to a second, third, fourth environment. So whether we're replicating between regions, clouds, to the cloud, back on-prem, the architecture will look the same. This is why we keep repeating the write once, deploy anywhere. It's not a mantra. It's what we should strive to do. As a technical person, I know this. If I do it once, let's automate it or create a shortcut because I'll probably have to do it again. So this same architecture, holistic management, reduced SEO, this is what we want to achieve. So the next question will be, okay, it's simple with 2 sites. Let's say it is. What about multi-cloud? Because that's another reality we're facing. Well, no problem. All the same, any cloud you want, deploy this smart DIH on different clouds, and you'll find that deployment, development, automating the entire process is so easy. So that's a lot of words, and we have to put the money where our mouth is. So what I suggest we actually do is move to a live demo to show you how easy it really is. Thank you.
Thank you, Tal. So yeah, now what I'm going to do is really show how it can be done, and very easy, really in few minutes, how we can move from on-prem deployment to a hybrid with replication and with enable to consume the data in multiple ways. So what we prepared for the demo, as you can see, this is the demo environment. What we have is DB2 database deployed in the on-prem environment, connected to a CDC. Again, it's an IBM CDC that we have a OEM is really part of our platform now. And our smart DIH cluster running on top of Red Hat OpenShift, again, in the on-prem environment. In the cloud for now, all we have is EKS cluster. Nothing is deployed there yet. And we also have a Mongo database that we want as an external data warehouse to send the data to it as well. So throughout the demo, I'm going to connect all those. So we will have our own pluggable connector framework deployed on top of the on-prem environment, enable us to connect through the CDC layer to the DB2 and really monitor to every change that is happening still in the system of records of the organization. In addition, I'm going to deploy Gigaspace in AWS on an EKS cluster, connected using our one gateway replication to the on-prem cluster, so the data will be available on the cloud as well. The mirror service, again, part of our offering, will send the traffic to the data, to the MongoDB as well. So in this case, MongoDB, but it can be really any external data source, can be even a data lake solution that you want to run analytics on top of it. And we will enable also the flow to it as well. And very important, of course, two-way to access the data using JDBC, using REST API very easily on cloud. And as you will see, using one platform, you don't need multiple vendors, you don't need to do tough integration, everything very, very easy in a simple way. So let's clean the board and start from scratch. The first thing I'm really going to do is deploy the Gigaspace Smart DIH on the EKS cluster. It will take a few minutes, so I'll start that and explain all others up until the few minutes that it will be deployed. So in order to deploy Gigaspaces, all you need to do is really run one simple command. We have Helm chart that deploy the entire platform, which is what we call the umbrella Helm chart that will bring all the benefit and will manage the entire deployment lifecycle. As you can see, this is Gigaspace is up Helm chart. I'm running it, and we'll see in a few seconds what is there, what is happening behind the scene. And just for you to see, for now, this is the URL to the cluster that will be ready. And this is the Kubernetes dashboard of the EKS. Sorry, make sure we're connected to it. For now, what we have is only ingress controller that I'm using to access the cluster. And here, since the Helm command started, as you can see here, the rest are starting to build up, and I will explain exactly what is happening throughout this demonstration. So let's give it 2-3 minutes to start, and let's, for now, focus on the on-prem. So in the on-prem, as mentioned, we have the OpenShift, and Gigaspace is already running, and this is the same, exact same software as I'm just deploying here. Let's go see that as well. So this is first the OpenShift UI. As you can see, we already have pods that are running. For the Helm chart that is deploying our platform is providing first our Gigaspace manager to manage the cluster. We have also the operator that works with the Kubernetes API. Doesn't matter if it's OpenShift, EKS, any Kubernetes stack. And in addition to that, we are providing Grafana that's with predefined dashboards, so you are able to monitor. And again, it's in one command, everything is starting. So this is ready, but for now, there is no data here because I haven't connected the pluggable connector yet. So now we're going to deploy the pluggable connector. And as you can see in this additional view, and this is the ops manager of Gigaspaces, we have already on-prem space that is ready to collect the data. For now, there is nothing inside of it, but I'm going to deploy the pluggable connector now, which connects through the CDC to the DB2 to enable the ingestion of the data to the on-prem cluster. So let's do that. Of course, again, it is managed via Kubernetes. So this is the access to the on-prem cluster. And let's see, I deployed into deploy. So we should see in a few seconds the pluggable connector here. You can see it here. Its container is being created. And once it will be created, we will also see it. We'll also see it here, and the data will be accessed through Gigaspaces. So let's see, since it's managed, of course, by OpenShift, I can see the logos here. I can see the progress of everything that I need. So once it will be completely up, I will be able to go back and also see it, and also see the data inside Gigaspaces. Again, our pluggable connector framework really enables us to connect to multiple types of system of records. In this case, it's DB2, but of course support others like Oracle, MySQL, SQL Server. And again, this is very, very useful. And for you, it's really agnostic at the end once the data comes to the platform. So we still need to wait a few more seconds until the pluggable connector will be up and fully connected to the system. For now, we can go and see the progress of the cluster on the on the cloud, and this is the cloud cluster. As you can see here, we really have the same thing now in the cloud. We have the manager, we have the Grafana and InfluxDB, we have the operator, and of course the ingress controller that is used as well for all the ingress traffic to the cluster. So let's see here. Progress. Few seconds. Here it is. The pluggable connector is done, and we now have data inside the on-prem cluster. So the data is available for the on-prem, but of course we want the hybrid solution. So let's see how can we do that. So the next phase will be really to deploy here the space that is ready to receive data. And I will also add the mirror connection. So everything that will be ingested to here to the space in the cloud will also be available in Mongo. So let's do that as well. Again, everything is done via Kubernetes APIs. So I'm simply running in this case, this is the Helm command that is deploying, this is the ZapPU Helm chart, and I'm using it to deploy for now the cloud space. And right after it, once it will be ready, I will also deploy the mirror service. So let's see the status. And now this is done on this level, but let's see if what here you can see the cloud space PU is starting. We have the first instance. In a few more seconds, we have the second one. I'm deploying it in high availability mode. So I have two containers, two pods that really, one of it is the primary and the other is the standby. So we also provide high availability. So let's go now and see if the platform is up as well from the Ops Manager. Again, this is the access to the cloud cluster, and I have the cloud space ready. So let's continue with the command to create the mirror. Here it is. Same thing. Again, it's additional PU. In this case, a mirror service that I'm deploying. And we should see it the same way through the Kubernetes dashboard. And also, once it's done, it is in the Kubernetes dashboard. And in addition, it is ready also in the Ops Manager. So we are almost there in terms of the entire data flow. We completed, we have data, we have the pluggable connector, everything is streaming here. We now have the ability to mirror the data to Mongo. And the last and important part before exposing the data is the one gateway replication. In order to those classes to be connected, I need to employ the one gateway. And as you probably understand, I'm going to use the same method. And now I'm going to deploy, sorry, the one gateway as a service in the cloud cluster. In this case, what will happen, of course, behind the scenes is that the one gateway will need to sync to the other cluster. This again will take a few seconds, should take about a minute. But in terms of the management and the visibility, I already see it. It's here, and of course, it is visible through the Kubernetes dashboard. So again, everything is here and about to be ready. So once the synchronization, which synchronization takes a few seconds to complete, but once it's there, every change that I will do will automatically go all the way. So I will be able, and I will do that later, update the database here. It will go through the entire flow to the cloud cluster and also to the mirror service to Mongo. We need to see what here it is. So we have now the data available in the cloud as well. We achieved the replication, as you can see, very easy. Few minutes, I deployed the cluster, created a replication, everything is working as it should. Of course, this replication is a secure replication, so there's no problem to run it over the network. Of course, you can have a secure channel underneath as well, but the traffic is secured. So we have it available on both sides. And we also, as you can see, we can go to Mongo as well, as this is Mongo just before I deployed. Those are the defaults database of Mongo. And now when I press the refresh, I have the cloud DB as well, and with the data that came all the way through. So I can really query it from everywhere. If I'm going, first of all, this is the on-prem. As you can see, I can use this as internal utility through the ops manager, and I have the data available. I can go, of course, and do the same. This is the cloud space. I can run the query, same type of data exists here as well. And we also saw it in Mongo. This is, again, if I'm going to this collection, then we have the same data, which is, of course, nice. But now we want to expose it to the outside world. For now, everything is internally. So in order to achieve that, I will do two things. One, deploy our data gateway, which enable SQL, ODBC, JDBC access to the platform. And right after it, enable a REST API access to it as well. Let's start with the data gateway. One option to deploy the data gateway is through the ops manager. Again, this is the cloud one. I can do the same on the on-prem, no problem. I'm deploying the data gateway service, running the apply, and we'll see in a few seconds that you'll see it also on the Kubernetes layer. Here, as you can see, this is the data gateway. Ignore this. This is, as you can see, the data gateway is installed. And now I can use any tool to connect to it externally. I'm using the dbeaver, and since our data gateway really implemented according to Postgres API, I can connect to it just like Postgres server. The only thing I need to do in this case is to put the IP of the ingress controller. Again, I enabled access through the ingress controller to the specific services that I need. The name of the database is cloud space. This is the name of the space that I have. And just pressing the button finish, and here it is trying to connect to the cluster. And as you can see, it was succeed, and I can see the tables here as well, the CD, the people, everything. Now we have access also externally using our data gateway, but we want also the REST API. So in order to achieve that, I'm going to deploy additional servers, which really on one end expose REST API, and on the other end use our Java SDK to run the query internally to get the data from the system. So let's do that as well using our Helm deployment. Let's see. I'm now deploying this get people service. So once it will be available in the cloud cluster, I'll be able to access it. As you can see, this is before. I'm trying to use the get people, and of course the service unavailable. The index controller replied that the service is not there. Now it is being deployed. This is the get people service. Once it will be green, I will be able to access it. Again, it's a stateless service that is running on top of our platform, enable us to get the data very easily, efficient from the cluster. Here is the get people. Now I can refresh it, and I received, in this case, very nice JSON with the entire data of this table, which is of course nice. And to show that we can also change everything along the way, this is now I'm connected to the on-prem DB2. This is the remote desktop to this DB2 server, and I can now change whatever I want. Again, it will go through the entire flow through the CDC, on-prem, cloud, and would be available to consume. Let's add additional row. Let's say we want to add tal. This is tal. Oh, sorry. Let's do it properly. Tal is probably about 10 years old. So here it is. I'm saving it to the DB2 directly. And now I can go back and try to fetch it. And this is, again, I'm fetching it on the cloud side. As you can see, I just hit the button because it's not orderly in ordered fashion. It's a bit harder, a bit more harder to see, but we get it. The entire, every update was really go through the entire flow. Here it is, and I can see it also. Sorry, in here, of course, when I'm running the query, everything is available. We can have it through the API. We can have it if we want it here in the cluster, in the on-prem cluster as well. Let's go and see it. Of course, it went all the way through. So this is it in all the flow throughout the entire channel of data. So you can see I updated DB2. It went through the on-prem cluster, then to the cloud cluster, and I was able to fetch it. Well, that's it. That's the demo. And again, only one platform can do it all, from the database to the cloud to the digital application, everything that you need, and very, very easy to manage. Thank you very much. And Tal, let's go back to you and see if we have questions about topics.
Okay, so thank you everyone for listening to the webinar. First of all, I want to make sure if there are any questions, if something wasn't clear, maybe the demo was too fast. If there is someone that wants to ask a question, this is a good time.
Yeah, we've got a question here from the audience. What we've seen here is a simple case of replicating from one database to another. But what happens when you have multiple data sources that pushed to multiple databases? On the other hand, is this something that the DIH can handle, and if so, how?
Right. So this is a good question. Yes, the DIH can handle multiple topologies. Of course, those topologies can be active-active, can also be active-passive, but active-active. So whether it's hub-spoke topologies, ring, federated, we can handle different topologies. And while data is pushed, maybe I'll go back to the previous slide. Even if data is being replicated from different databases and being pushed on the other environment to different databases. For example, some of it will be pushed to Mongo, some of it to MySQL, some of it to another database. It doesn't matter, because the fact of the matter is that, as we've seen in the demo, the hub here, whether it's the on-prem or the cloud, the hub consolidates the data. It doesn't rely on the data here, because when a business application queries the hub, it doesn't delegate the query. It simply returns the data that already exists in the hub. So there is no problem replicating from many to many, and data is available. And for the sake of argument, even if this Mongo database goes down for whatever reason, data is still available in the hub. So not only it's simpler, we're also gaining another level of high availability for our entire architecture. I hope that answered the question. I know I've been a bit more thorough than I probably should have been. Are there any other questions? If not, I'll just read one. Yep.
Yeah, sorry, Dinesh asked the following questions. If the source database is a TB, how do you handle the replication of the initial data load in the target database?
If the what is the initial source database? What is it say?
TB.
TB. Are we talking about terabytes, or let me see? I'm not clear on the.
Dinesh, if you want, we can allow you to speak, and you can ask it Tal now if you want.
Or you can consider any RDB. Okay, if I understand the question correctly, we can handle replication from different databases. It doesn't have to be necessarily relational databases. I know DB2, it is relational, but it could have been from other database types. We have pluggable connector framework. It's a generic framework that even if there is something we don't support to read or to write to, you can override the endpoint and insert your own CRUD operations. Oh, I see database in terabytes, right? So no problems. Our customers are replicating terabytes upon terabytes of data. I've seen even tens of terabytes which are being replicated between clusters. It goes without saying that if we're talking about replicating databases which are tens of terabytes in size, it will take time. With that being said, we have evaluated in our innovation labs, and I've also experimented myself. We are utilizing the full bandwidth of the connection between the different sites. So if you're deploying it on the cloud, whichever bandwidth you will pay for, if it's 1 gigabit, 5 gigabit, whatever you pay for, we'll be able to utilize it. But it will take a while to replicate terabytes of data. In the meantime, while it is being replicated, keep in mind it's available on the smart DIH cluster. So you can, if you have a load balancer, you can route digital services, for example, on the cloud, you can route them to the on-prem cluster. And once databases finish replicating, you can simply change the load balancer and route them to the Gigaspace's smart DIH cluster on the cloud. So there are ways to do it. I'm sure our delivery architects have much more expertise in this than I do.
And maybe worth mentioning, of course, is that and when talking about terabytes of data, we're also providing the multi-tier capability. So when you really decide if you want to store it in RAM, in SSD, and the ratio between them. So again, the replication will take time, but it will be available in order manners according to your needs.
Thank you, Dinesh. Any additional questions?
If not, I'll just recap. So we've seen a very cool...
Attendees, please type them in the Q&A model at the bottom.
Oh, I see. How do you see your product in comparison to Oracle Golden Gate? Oh, Dinesh, that's a great question. So first of all, our platform has a lot of capabilities. We're not competing with just a replication project. The way we see ourselves is a digital integration hub. The replication is a subset of our offering, an important subset. Now, Golden Gate is purely a CDC replication tool, mainly used to replicate from databases to databases. Majority of the deployments I've seen in the market, and I've seen of deployments for my time in Oracle, we're replicating data from Oracle database to Oracle database, but it does support a few others, but it's mostly Oracle to Oracle. That's usually the majority of people who use Golden Gate, what they replicate from. We have, again, our CDC capabilities and enhanced capabilities compete head to head. But again, it's part of the project. The real project, or should I say the bigger picture, and it also goes with what we want to conclude, is building this hub. Now, this hub that we're building you need to replicate data to the hub and between the sites. So it's not just about moving data from one site to another, it's about making it available. And if you use Golden Gate, which obviously you can, it means you still need another solution to store your relational data, another solution to store your semi-structured data. You need data pipeline solution, you need a microservices platform, you need other replication tools to potentially push it to databases that Golden Gate doesn't support. So you'll start building this hub with your own tools, which I'm putting cost aside. Effort-wise, it's a big deal. An integration project is never easy, but the more you can get out of a platform, the more capabilities, the simpler the integration project will be to go live, the simpler it will be to manage down the road, and obviously the simpler it will be to upgrade and deploy new services. So in a do-it-yourself project, you might spend between days and weeks on deployment of new digital services. Once you have Smart DIH, Gigaspaces DIH up and running, it could be between hours and, well, I want to say days, depending on the type of service, but it'll be much, much faster because you don't have as many tools you need to maintain, Golden Gate being one of them. I hope that makes sense. Yes, the deck will be sent, and of course, both myself, Yaki, other architects, everyone is available for further discussions. We love challenges, and please, lay it on us. Thank you.
Thank you.
The recording will be sent within the hour to all registrants. So thank you for attending and join us for the next webinar.